Hello everyone, so today we are going to discuss about how we will refine the solution of ill-conditioned equation. So basically what is ill-conditioned equation? We will discuss it with the help of an example. So first the example would be 2.500x plus 5.200y is equal to 6.200 and 1.251x plus 2.605y is equals to 3.152. So basically the values of x and y will be 0.32794 E2 and y will be minus 0.16958. So we have another equation that is very similar to this, but there is a little difference that in the value of the second equation of y, the value of y will be 2.606y and the values and the answers will be changed drastically. So the value of x is equals to 0.2352 E2 and y is equals to 0.1250 E2. Even with the matrices row interchanges, the solution will have same rounding error, iterative refinement, which leads to reduced rounding errors and often a reasonable solution for some ill-conditioned problems is obtained. Basically, we have three equations: a11x1 plus a12x2 plus a13x3 is equals to a14. The second equation will be a21x1 and a22x2 plus a23x3 is equals to a24, and the third equation will be a31x1 plus a32x2 plus a33x3 is equals to a34. So let x1 at 0 iteration, x2 at 0 iteration and x3 at 0 iteration will be approximated solution obtained from the Gaussian elimination procedure. For that we will have three equations will be a11 x1 at 0 iteration, a12 x2 at 0 iteration, a13 x3 at 0 equation, and a is equals to a14 at 0 iteration. Similarly, we have another two equations, that is a21x1 at 0 iteration, a22x2 at 0 iteration and a23x3 at 0 iteration is equals to a24. And third equation will be a31x1 0 plus a32x2 at 0 iteration and a33x3 at 0 iteration is equals to a34. Actually, what we will do that we will subtract the main equation, real equation, with this the first iteration of this equations. So we will substitute these solutions on the left side of this equations, and we will have a14 minus a14 at 0 iteration, and we will get the value of, let it say that alpha 14 at 0 iteration. Similarly, we will get the value of a24 minus a24 at 0 iteration, and we will get the value of alpha 24 at 0 iteration. And similarly, we will get the value of a34 minus a34 at 0 iteration. It will give the value of alpha 34 at 0 equations are larger than x1 at 0 iteration, x2 at 0 iteration and x3 at 0 iteration are not good solutions. Now we will subtract these equations, equation 1, equation 2 and equation 3 from the actual equations. We will get a11 e1 at 0 iteration plus a12 e2 at 0 iteration and a13 e3 at 0 iteration is equals to alpha 14 at 0 iteration. Similarly, we will have a21 e1 at 0 iteration plus a22 e2 at 0 iteration and plus a23 e3 at 0 iteration is equals to alpha 24 at 0 iteration. This will be the fifth equation, and the above will be the fourth equation. We will have a sixth equation, that is a31 e1 at 0 plus a32 e2 0 plus a33 e3 is equals to a34. From the equations, we have concluded the value of E1 at 0 iteration will be x1 minus x1 at 0 iteration. E2 will be error 2 will at 0 iteration will be x2 minus x2 at 0 iteration, and E3 0 will be x3 minus x3 0. These equations can be solved by Gaussian elimination and values of EIs obtained. The new approximation to the solutions is xi at 1 iteration is equal to xi at 0 iteration plus ei plus at 0 iteration. This procedure may be repeated by substituting xi1 in general equation and further requirements to solution obtained. It has been found that a few cycles of refinement procedure lead to more accurate solutions in ill-conditioned systems.